H-L Congruence theorem. Let's draw a right triangle and say it has lengths so say this is 15 and this is 20 and this is 25. So the legs are 15, 20 and the hypotenuse is 25. This is just a scaled version of 3, 4, 5 triangle. Now what I'm going to do is I'm going to draw another right triangle that has the same hypotenuse of 25 but the legs are going to be different. So let's say this is 7, 24. Now you can check that they are right triangles using Pythagorean theorem. So they have same hypotenuse, but obviously they are not congruent. So even if two hypotenuses are equal, that does not mean that the triangles are going to be congruent. However, now let me draw two other right triangles. So this is a right triangle and say I'm going to draw another right triangle. So this time the hypotenuse of one matches with that of the other. So this is the right angle. And in addition, if I have one of the legs match the legs of the other right triangle, then these two will be congruent. And we can see why. Because in right triangles, we have Pythagorean theorem, and Pythagorean theorem will force the other two legs also to be equal. So say if this leg was x and this was z, then the Pythagorean theorem will give us the length of this line segment or this leg to be square root of z square minus x square. Now, if I'm saying that these two legs match, that means this is also x and this is z. That means this is also going to be equal to square root of z square minus x square. And then we can apply H-L Congruence rule to say that these two triangles are congruent. So in a right triangle, we have something called H-L, H for hypotenuse and L for leg. So if hypotenuse and a leg match, then these two triangles will be congruent. Now H-L Congruence theorem finds its applications in many problems, so it might be a good idea to know this.